Okay. So basically, yeah. All right. So yesterday we did it till here, I believe. If you guys have any questions about the last question, do let me know. Otherwise, I'll just go forward then. Okay. Now, let's roll. So, speaking of this, then, the next question is. Oh, yeah. Okay. So, this one is a very similar question like the first one we did. Okay. So, this will be your homework. And obviously, yeah, this will be homework. So these are like this one because these questions repeat a lot. So just do them. This is also your homework. I don't know if there was another question. Yeah, this one. Homework, please. Okay. And yeah. So 4 questions as homework, and then we're gonna go towards 2-dimensional momentum. Okay. Okay. So about like 2-dimensional momentum, I just want to tell you a few things. Yes? Yes, I can. Yes, well. Question number 3B. Wait a second. You send me some question? Wait a second. 3B. Are you talking about this one? Chini? Okay. Alright. So I have no idea what you're saying. After the
Sir, it is a ball explosion.
ball explosion. Okay. Alright. Everybody, is my voice
It is
alright?
after.
Yes, it's clear.
Okay. Ali, then it's your problem. Okay. Yes. This one?
Sir, इससे जो बाद में है वो number 3.
Number 3. This one. You want me to explain this to you? Okay.
Or B.
So let's do this.
Just the B part there.
Alright. So in this question it says that basically an object A of mass 4.2 kgs, horizontal velocity this, moves towards object B as shown. Object B of a mass 1.5 kg is moving along horizontal velocity 1.2. Fine. And then they collide, they move together to the right. Okay. So we're just gonna basically use m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. We're gonna assign the directions. Let's suppose we're taking right side as positive and left side as negative. So we're gonna take this as positive, take this as negative, take this as positive, and this will be positive as well because they have given it already. Okay. So then what we're going to do is we're going to add them. So 4.2 times 3.6, then plus 1.5, Walaikum Salam, minus 1.2, and then afterwards it's like Sohail 4.2 times V plus 1.5 times 3. So then let's try and do this. 4.2 times 3.6.
It's 2.1.
Okay, so V will be 2.1 meters per second. Okay, all right. Now it says determine whether the collision is elastic or inelastic. So there are a couple of ways of doing this. I would still prefer that you use U1 minus U2 equals to V2 minus V1. You can do that, or you can use the kinetic energy equation. It's up to you. Okay, now for that, initially it was going 3.6, and the first one initial velocity was minus 1.2, so minus 1.2 equals to, afterwards it was 3 minus what is this, 1.2.1. So what you get then, yes please, this would be,
They are not equal.
they're not equal, right? So you get this, you write this, and because they're not equal, so you write,
So it's 1.5 on the left side and 1.8 on the right.
interesting, that could not be there. If you, it will be plus, right? So 3.6 plus 1.2 will be, I think, 4.8, and that's,
Oh, sorry.
yeah. So this is not
Yeah, good
equal,
one.
so the collision is inelastic. You can do that. Okay, Sohail. Do you understand my point now?
Sir, the one in which we have done V2 minus V1, won't it be like 2.1 minus 3.0, because V2 is like after the collision?
This is U1, this is U2.
Oh, no, sorry, sir. I got it.
Okay, do you understand now? Okay. Alright, wait a second, please.
Sir, it's actually 3.6 minus 2.1 and then 3 minus 1.2.
3.6 minus 1.2, yeah. And 3
Why minus
minus,
1.2? Why not 2.1? Because for object A, velocity after collision is 2.1.
but we are looking at the initial velocity, Javeria. That's why.
Oh, okay.
Do you understand? Now,
Yes, sir.
alternatively, obviously, you could also do like kinetic energy, right? You can find kinetic energy before and after, but that would be very long, right? And I would not recommend that at all. Okay, is it clear? Okay.
Also, sir, there was this MCQ that you gave in homework. It was above this, in which there was a stationary clay. Can you please help with that?
Above
Stationary palette.
stationary pellet. This one? You want me to help in this one? Okay. Alright, I'll do that. So it says a lead pellet is shot vertically upwards into clay block that is stationary at the moment but is able to rise freely after impact. Okay, fine. So it has a mass, it has a speed, and obviously this is the U1 speed, the U2 is 0. Okay, so we can write it like that. And then it says the pellet hits the block and within initial velocity and embeds. So this is case 2 that I told you. And then it says how above its initial position will the block rise. And yeah, never mind. So first of all, we are gonna basically use case 2. So I'm gonna write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now, interestingly, if I take up as positive, if I take down as negative, then obviously I would say let's take this as positive, and after that the pellet and the block go together with a certain velocity. So I'm going to write that as positive as well. Anyway, so the mass, oh no, what is this? Okay, so the mass is 0.005 because we got divided by 1000, right? And then times 200 plus the mass of that is 95, which makes it 0.095 times 0. And afterwards you got to add the masses and you got to multiply them with the same velocity. Okay, so can you find V, please?
So it's 10.
It's 10. So 10 meters per second would be the answer, right? Oh no, what happened? Why did my stream stop? Wait a second, please. Oh my goodness. I know why. Wait a second, please. It's bumped. Where is it? Where is it? Where is it? Where is it? Oh. Okay, I'm sorry. Okay, so yes, y0. Ali, which part you're saying about the stationary clay? The stationary clay will be 0 because it says initially the block is stationary, that's why. Okay, that's why I put it 0. And then you got 10. Now what you're going to do is, you know that SUVAT, so initial velocity is 10, initial velocity is 10. We got to find the height, so displacement is this. Final we don't know. Final has to be 0, right? Because at maximum height vertically it would be 0. Acceleration will be minus 9.81 because it is going against gravity and time is not given. So we're going to use 2as equals to v squared minus u squared. So 2 times minus 9.81 times height equals 2. This will be 0 squared, this will be 10 whole squared. Can you guys find h, please? Interesting.
It's 5.1.
It's 5.1? 5.1?
Yes. Sir, why are we using the initial velocity as 10?
Because when this pellet hit, right, it was 0. When it hit, they got this as their velocity, right? This is when it would start rising up. Do you understand? That's why. Okay. Do you understand now?
Yes, sir.
Okay, very good. All right. Then going to the next one. Everybody understands this? Any questions still you guys have? Let me know. Okay. Now do try it yourself as well, so you guys can actually attempt it again and see if you can do it now. Anyway, today I just wanted to go to two-dimensional momentum, which is very, very important actually. And these days I've noticed that two-dimensional momentum questions are very, common. So we got to do this. Now, for two-dimensional momentum, what you guys need to remember is you need to break momentum into horizontal and vertical directions. All right, just like we do with the vectors. And then you guys need to apply law of conservation in both the directions separately, and this way you can solve these questions. So this is the only tip that I want to give you. So let's move to the question so you guys understand what this is. So what it says is that basically two balls X and Y move along a horizontal frictionless surface as illustrated. Ball X has an initial velocity of 3 and direction AB. And then ball Y has a mass of 2.5 and its velocity is 9.6, okay? Yeah, and it's 60 degrees to line AB, fine. Two balls collide at point B. The balls stick together, all right? So this is the case 2, basically we're looking at. And then travel along the same horizontal surface in the direction right angles to the shown, right? They go vertical. All right, now. So it says by considering the components of momentum in the direction line AB, which is horizontal, show that the ball has a mass of 4 kg. This is what we're going to do. Now, please check this out. This is very important. So first of all, because line AB is horizontal, as you can see right here, so we are going to look at the components that are horizontal only. So again, in the horizontal direction, I'm going to write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. And also, I'm going to take this side as positive and this side as negative. That's up to me, like you guys already know. But you can actually change it whatever you want to, like. It's up to you, really. Then, what happens next is that we have to make the components. So this is already horizontal, great. But this one will have one component this way and one component this way, because this is angle 60, which makes this angle as 60 as well, because these are corresponding angles, okay? So this makes it 9.6 cosine of 60, and this one is 9.6 sine of 60. And how do I know which one is cosine, which one is sine? By just looking at the angle. So where the angles hits, right? So angle is made between the original vector, which is the speed, and the one that is cosine, and the one that is not next to the angle will always be sine. All right, Laiba, is it clear? Okay, now what I'm going to do is I'm going to basically, I have resolved it into components, and afterwards, if you see, afterwards both of them just go, vertical, which means horizontally the momentum was completely zero. There was nothing going in the horizontal direction. So that's what we need to understand. Okay, now let's do this. So now I'm going to make the equation. The first mass, we were to find that the speed was already horizontal, that was 3. The second mass was 2.5, and the horizontal component was in this direction, which has to be negative according to my sign convention. So I'm going to write 2.5 times 9.6 cos 60. So 2.5, and this will be minus 9.6 cos of 60 equals to Now, afterwards, because both of the balls go vertically upwards, which means the momentum has to be zero. None of the balls have any momentum in the horizontal direction. So I'm just gonna write that comment so you guys remember later. Because none of the balls have horizontal velocity afterwards. Okay, so you just need to look at like this, and we need to show this, right? So now we're going to solve this, and this will be 3m, and obviously that's going to be
12.
yeah, that's minus 12. Should be minus 12
Yes, sir, minus 1.
equals to 0. Wajiha, you're late, that's not good. And 12 will go here, and mass will be 12 divided by 3, so it's going to be 4.0 kilograms, which is shown. All right, anybody who could not understand this, please let me know. Okay, so this way what we have done is we have basically taken one side and then just looked at all the velocities to that side, just like we have done vectors, and we have applied law of conservation that side, and we have been, you know, very lucky to find the right answer. All right, very good. Okay, you can write this down and take like 10 seconds to absorb it, and then let me know if you understand this. Okay, Yaya, are you getting everything? And both Khatijas and Javeria, Munim, Sultanat, Umar, Zahan, Ali, everything's good?
Yes, sir.
Okay, all right. Where is Aman today? She skipped the class, that's not good. All right, Ahmed, do you understand?
Yes.
Okay, so then I'm gonna go to the next part. It says calculate the common speed of two balls after the collision. Now, what you need to understand is that now, because afterwards they're going in the vertical direction, so now we need to apply the law of conservation in the vertical direction only, which means for vertical only, we're going to write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, and only see vertical components, all right, in this one, so nothing else. So right now, if we go back, you might realize that this object has no vertical momentum, so this will have vertical velocity as 0. So initial vertical is 0, so u1 is 0 basically, and this one has a vertical component, which is this one, and let's call this u2, and afterwards they have this speed and they've combined, so we're going to use this. Let's take up as positive, down as negative, which makes this as positive and this as positive as well. Now, so this is going to be 4 times 0, because initial vertical velocity was 0, plus 2.5 times 9.6 sine of 60 equals to, because they combined after hitting, so we're going to add their masses because this is case 2, and they go with a similar velocity. So we're just applying everything that we've learned, and we're just applying that, and then we're, you know, just finding it in the vertical direction. Okay, so now keeping that in mind, then okay, so keeping that in mind, this will be 0. Can you guys help me, please? This will be, I think, 6.5, and I don't know what that might be.
Sir, it's 20.78.
and V will be then 20.78 divided by 6.5, and that is
3.2.
3.2, right? So 3.2 meters per second should be your answer. Is there anyone who could not understand that, who still thinks it's a bit tricky? Please let me know. Okay. Now, the last part is very, very easy. Well, all parts are easy, but this last part is particularly very easy. It just says determine the difference between the initial kinetic energy of ball X and the initial kinetic energy of ball Y. In kinetic energy, the directions don't matter because that's basically a scalar quantity. Initially, ball X was going in this direction with, I believe, velocity of 3, and it has 4 mass, and Y was going probably in this direction with velocity of 9.6, and the mass was 2.5. So we're just going to find the initial kinetic energies. We're going to say this will be half times 4.0 times 3.0 whole square, and this will be half times 2.5 times 9.6 whole square. Can you please help me find both the answers? All right.
The first one.
The
Yes.
first one is 18.
18 joules. Okay. And the second one?
115.2.
115. 15.2 joules. Okay, you got to find the difference in that. So 1.52 minus 18, and that would be
97.2.
97.2. So either you can get away with this, or you can just write 97 joules. Both answers correct. Please do not attempt to write it as 100, and neither something larger than 97.2. That would be wrong. Okay. Okay. Yes. Sultanat, Yaya, Wajiha, everything's clear?
Yes, sir. Yes, sir.
Okay, pretty good. Okay, so now these sort of questions are very common these days, but then this question is a bit different. Okay, and this question is related to vectors as well. So I'm going to solve this, and then you guys can look at it. So this is what they say happened before collision, and this is what they've said after collision. They say what is the vector diagram that basically shows the momenta before and after. It is very simple. You don't need to worry about that at all. What you're going to do is, because you know that this vector, see, this vector is like this, right? And this vector is like this. So you're going to pick this vector and place it right here, wherever it is, right? And it would be somewhat like, you know, if this is M, then you can make this as a head to tail rule. Okay, let me just draw it like that. So you're going to make it as head to tail rule. So this vector is going to be M U2, and then obviously both of them have just one result, which is this vector. And how do I know it will be here? Because when you make two vectors, this is like head to tail, and then this one will be basically mu plus m times 0. Okay, and it should start from the start of the drawing and should end, that would be the resultant. So we are looking at something like this, right? Unfortunately, they have given us the other half, like they have given us down. Even if they have done that, do not worry. You can make the first vector like this, which is m u by 2. The other vector like this from the head to tail, right? This will be m u3, and then the last vector will be from the start to the end, just like the vectors are, which is mu plus m times 0. Okay, now in this one, let's check which one is correct then. And I believe this vector a should be the right answer, right? Is that clear, everyone? Or is it? No, it's not a, it's b actually. It's not a. Now the difference between a and b is because this angle has to be beta and the angle is right next to mu2, so this is correct. In this one it was alpha, which was right here. That is wrong. That's why b is the correct answer. These two are absolutely wrong. How do I know this? I know this because in both these a and b, you might see that they have right head to tail. This also has the right head to tail. These ones do not. Like you can see, one vector is going like this, which is opposite direction. So this is not to head to tail at all. And this is also wrong because this is not head to tail at all. Alright, that's fine. Okay, any questions now? Please let me know. It is just the same way we do with vectors. So even if it is momentum, you don't have to, look at it as momentum. You just need to see it as a normal vector that we solve. All right. Okay. Any questions now? Please let me know. Okay. Pretty good, huh? Okay, so going to this one now, I believe you guys can now solve this question on your own because this is pretty simple. That would be your homework. And also, if you do the previous one, obviously you can also do this one, and this is the same thing, but I would like to solve this small question, and that would be the end of the class then. Okay. So in this question, it says that a ball of mass 0.20 kilograms traveling in direction x at the speed of this collides with a ball of this traveling in direction y with the speed of this. Fine. The balls stick together after collision and they move at an angle theta to x direction. They stick together and they're going in this direction with some value, I don't know. Have they said it? They've said nothing about the speed, right? Very, very interesting. Okay. It doesn't really matter. We're going to find that anyway. So what we are really looking at here is that obviously this is before the collision and that is after the collision. This is fairly, I think this question is fairly new. Yeah, 18. So afterwards it will have two components. Obviously one component has to be the horizontal component, so let's call this h, and one component has to be vertical component, which is v. Okay, so first of all, let's try and solve this with horizontal, and then when we're done with horizontal, we're going to use vertical and then see what happens. Anyway, so for horizontal, we're going to write the equation as m1 u1 plus m2 u2 equals m1 v1 plus m2 v2, and we are only looking at horizontal things only. Okay, so let's try and put some values in it. So the first value is the mass, which is 0.20. I'm gonna take, okay, let's take this direction as positive and this direction as positive. This direction would be negative, upward is negative as well, just for a change. Okay, which makes this as positive, this as positive as well, and this has positive and this positive as well. Okay, so this would make things a bit easy for me. Anyway, so it's going to be 0.50, and this one has 0.30, and because it is completely vertical, so I'm going to add 0 here. I'm not going to use 0.40 because I'm solving it for the horizontal direction only. Is it clear, everyone? All right. Afterwards, the masses combine, which is like 0.20 because they stick together, plus 0.30, and they move with the velocity v. This is going to be, I think, let's try and solve this. 0.2 times 0.5, which is 0.1, and plus 0, and this is going to be 0.50 times v. Okay, so 0.1 divided by 0. Oh, wait, yeah, okay, so this is going to be 0.5 times v. So this is for horizontal only, right? So we're gonna get 0.1 divided by 0.5, and that's 0.2. Interesting. So it means the horizontal velocity is 0.2 meters per second. Is it clear, everyone?
Yes, sir.
Then we're going to do the same thing for the vertical one. So we're going to write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. We're going to say 0.20, and this time, because it is completely horizontal, so we're going to add 0 here because it has no vertical velocity, plus m2 will be 0.30. It does have a vertical velocity, so we're going to write 0.40. Afterwards, they stick together and they're moving at velocity, which is vertical. We are finding this one. Okay, so this will be 0 plus let me just try and solve this here. So 0.3 times 0.4, which is 0.12, equals to 0.50 times v, which is 0.12 divided by 0.50 equals to v. So I'm going to write 0.12 divided by 0.50, and the v comes out to be 0.24 meters per second, which is this value. Okay, because I need this angle, and this angle is next to this vector, that makes this vector as adjacent and this vector as opposite. So I'm going to just use tan theta. I'm going to write tan theta is equal to perpendicular, or the opposite, over the adjacent, which is 0.2, and then tan of inverse equals to 0.24, 0.2. Okay, most of the people might get it wrong because you might have your calculator in radian mode because of math class. Please do change that and put it to degrees, and then divide it by 0.2, and that should come out as 50.2 degrees, which is exactly this answer. Okay, anyone who could not understand this still, please let me know. Okay, so that's pretty good. All right, Aman is still not here. Okay, never mind. Ahmed Javaria Khadija squares 0.2 से divide क्यों किया? Okay, all right. Why did I do 0.2 divide like 0.24? So basically my vectors were like this. This is the angle, this is like 0.2, and this is 0.24. Okay, right? If you look at this vector, this is what the v. This side is next to the angle, which makes this as adjacent, and this side is opposite because it's not next to the angle, that makes it opposite. Tan theta itself is basically opposite over the adjacent, and that's why I did it. Do you understand, Ryan? Right. Anything else? Okay. Khadija Squares, do you understand? Daiba, Ali, Munim?
Yes, sir.
Ryan, Sultanat, Suhail?
Yes, sir.
Okay. And about Umar Shahzad and Wajiha,
Yes, sir.
Yaya and Zahan. Everything is clear? 100%? Okay. Now you guys need to attempt the questions that I've given you as as homework, okay? Now we have about
sir.
20 minutes still left. If you guys have any other question that you want to, discuss, it could be like out of this chapter as well, or something you've done in school, you can also ask me that, okay?